circumstances, most of the time what you are going to be coding is not going to be straightforward. It's not going to be 2 is always equal to 3 or 3 is always equal to 5. But sometimes it may be that you want to compare apples to apples or apples to peach to find out if apples are actually apples or peach are actually peach. You understand? So that brings us to conditional statements. Now, in order to type conditional statements in Python, what we do is, okay, let me just write a conditional statement. Hope you can still see my screen. Okay, now for conditional statements, in order to type a conditional statement in Python, you use what they call the if command. It's a keyword in Python. Now, if you type if, you simply say if, for example, if 2 equals to 3. Did you see what I just did? Now, I just typed if 2 equals to. Now, I did not write the equal to once. I wrote the equal to twice. Now, the typing equal to twice simply means that you are telling the computer that I am comparing 2 to 3 and I'm not assigning 3 to 2. Hope it makes sense. Please confirm. Hope it makes sense. Are we there? Okay, wonderful. So, So now, if 2 is equal to 3, we want the computer to print something. We want it to print something like, say, okay, let it tell us that it's true. Now, if 2 is equal to 3, it should print 2. Now, that means that if 2 is not equal to 3, it will not print anything. So let's try that out. Have you noticed that it didn't print anything? Because automatically it's telling us that 2 is not equal to 3. Which means that 2 is not equal to 3. Now, let's change the variable 3 to 2. Now, let's say if 2 is equal to 2, print true. Let's type. You see that it is printing true. Because it has confirmed that 2 definitely is equal to 2. Now, other conditional statements, other conditions that you could use include not equal to. It also, we have greater than, we have less than, we have greater than, less than or equal to. We have greater than or equal to. Each of these things do different things. Now, the first one is, we have already talked about equal to, which is this. Now, this is equal to. This is not equal to. This is greater than. This is less than. This is less than or equal to. This is greater than or equal to. Now, from here, you will notice that we have about 6 conditional statements, conditional conditions that we could look at. We could look at if something is equal to another one. We could look at if something is not equal to another one. We could look at if something is greater than another one. We could look at if something is less than another one. We could look at if something is less than or equal to another variable. We could look at if something is greater than or equal to another variable. Now, let's try all of them out. Okay, sorry, I didn't do this to. This is not supposed to be put. Let's make it a raw information. That's why I've given that error. Okay, now let's do something. Now let's put this to practice. Now let's assume we have a variable A. A is equal to 5,000. We have a variable B. B is equal to, say, 7,500. We have a variable C, which is equal to, say, let's give it 3456.78. Any value. Let's say we have a variable D, which is equal to, this is it. Then let's have another variable E, this is variable E, which is also equal to which is also equal to this is it. Then we have a variable f, which is equal to Python. Python is something, anything. Python is awesome. Now, let's carry out conditional statements on this. Now, let's say we want to compare A to B. What we simply need to do is simply say that if A equals B, do this. Print A equals B. Now, if the condition is not met, we need the computer to do something else. That brings us to another conditional statement, which is always attached to the if statement in Python, which is called the else. Now, else simply means that if condition A, the first condition is not met, do this, which we simply say print A is not equal to B. Something like this. Most of this I'm at coding. So later on we'll learn how not to add code things in programming. Because eventually when we start building real life applications, we won't be at coding anything like this. Most of the variables will be gotten from a particular source, most likely a database. So then we would have touched those particular topics. Now let's press Shift Enter. You'll notice that it is telling us that A is not equal to B. Now, what is the condition that we gave it? We told it that if A equals to B, now A is 5,000 and B is 7,000. So what we've told the computer is that if A equals to B, print that A equals B. But else, if A is not equal to B, print A is not equal to B. Now the computer has gone to the variables that we have, which are A and B, and seen 5,000 and 75, and simply says that, okay, is A equal to B? No. We now go straight to the else statement, which is printing A is not equal to B. So it has printed A is not equal to B. Now let's try something else. Let's say if D is equal to E, print true. Then, now, see what I'm going to do here. Now, instead of writing else, I won't write any else statement here. I'll simply say, instead, print false. False. Oh, sorry. You notice here it has told me that there is an invalid syntax because I typed D equals E, which means that I have assigned the variable E to D instead of compare the variable D to E. So I simply say D equal to E, which is this. So I press Shift Return. It is telling me, okay, sorry, let's put the else. Let's put the else. When we get to actual real life code, we will not use else. For Jupyter code, let's just use else. Now you see it's printing true because the variable D, which is this is it, is equal to the variable E, which is also this is it. Now let's try something. Let's say if D is not equal to E, print none. Let's just say print none, something. I'm just printing anything off the top of my head. Then we simply say else. Print, let's just anything. Absolute. Let's just say absolute, something like that. So we can just get a value. Okay. Now you see that it's saying it's printing absolute because from here we know very well that D is equal to E. We know that D is equal to E. So we have asked it, is D not equal to E? D is equal to E, which means it will not print none. Else, it will now go straight to the else statement and print absolute, which is telling us that D is equal to E. Now let's try something else on this one. Today's class, I'm going to be dropping a particular topic that I want us to work on personally at home. We've touched variables, we've touched data types, we've touched arithmetic operations, and we are now touching conditional statements. So what I'm going to do is I'm going to give some kind of assignment, because I don't know if everybody has been practicing on their own, but I'm going to give some kind of assignment that we will look at. The assignment will be submitted. I will give the assignment before tomorrow morning, so that we can just use it to test our knowledge on what we've done so far. Now let's look at greater than. Let's say if A is greater than B, print A, else print B. Okay, that's what it prints. It prints B. He's asking us if A is greater than, is A greater than B? No. A is 5,000 and B is 75. So he's telling us to print A. It cannot print A because A is not greater than B. Else it is printing B. Okay, now let's move on. Now, you remember I mentioned earlier that we have several of them. We have equal to, we have not equal to, we have greater than, we have less than, we have less than or equal to, we have greater than or equal to. Each of these things perform different tasks. Now, like the equal to, like we looked at earlier, it means that both variables must be the same. The not equal to means that both variables cannot be the same. If they are the same, which means it is false. Now, greater than means that one of the variables that we are comparing must be greater than the variable we are comparing it to. Less than means that the variable we are comparing must be less than the variable we are comparing it to. Less than or equal to means that the variable we are comparing must be less than or equal to the variable we are comparing it with. Greater than or equal to, it means that the variable we are comparing must be greater than or equal to the variable we are comparing it to. Which means that whenever we are going to practice something, I'll give us something that we would need to use most of these functions, most of these conditional statements. Are we flowing? Please ask any question if you. Please ask any question now, please. Okay, somebody asked if we have recordings of this meeting. Yes, we do have recordings of this meeting. We do have a recording of this meeting. So if you have any question, if I can go on, please indicate by saying yes. Please indicate by saying yes, if I can move on. Are we there? Are we there, please? Okay. Thank you. All right. So let's move on. All right. So now, like I said before, there is equal to, there is not equal to, there is greater than, there is less than or equal to, there is greater than or equal to. Now let's move to the next topic. I don't want us to spend too long on these basics, because eventually the end point is just applying this in real life applications. Now, let's say we want to, for example, we have a list of values. Let's declare a list. You still remember how to declare a list? You can say, let's say list underscore A equals square brackets 2, 3, 5, 6, 7. I am here. Then 2 again. Then 5. Then 8.657 and the likes. Now we have declared this list. Now we want to find out, we want to print every element of this list. Do we start writing print, which will still work but is inefficient? We can simply type print list. Print list list underscore A1, A0. Then we'll now copy and paste this and start pasting. Sorry. Then we keep pasting. Then we now put what here? We put 1, we put 2, we put 2, we put 3, we put 4. This will do the job, no doubt. This will do the job because it will print each index of the list. It has printed 2, it has printed 3, it has printed 5, it has printed 6, which is it. But imagine if you had a list. For example, if you had an Excel sheet of say 500,000 rows, and you need to print each row, and you need each row to carry out a particular task for you. What do? In that particular case, it becomes very, very, very tedious. Because at the end of the day, you discover that you cannot go through that large file like this. So that brings us to loops. Now, loop simply means that we are going to be looping through a value to get all the values involved in that value. Let me explain what I just said. Now, see, this particular line of code is grossly inefficient. So in order to go through this particular list, what we needed to do was just say, we can simply type what they call for. For X in list A. I will explain what I'm doing now, please. We'll print X. You notice these simple 2 lines of code have done the same thing that we did before, more efficiently. It has done the same thing we did before, more efficiently. So what this means is that now, for example, we are saying for the values, this X could be anything of your choice. It could be Y, it could be anything. When we get to real code, we will no longer use X. We will use variables that tally in line with the code that we are writing. Now we say for X in list A, we've declared list A as a list, which is this. Then we said print X, which is this. So we are saying print every element of list A. Okay, we are simply saying that print every element of list A. Now we have a list A here. We have 2, we have 3, we have 5, we have 6. We are saying that print every element of list A. So we simply say, we said for all the elements in list A, which is represented by X, print X. So what this for loop will do is that it will start going into each element. The first element is 2, it will print 2. Then it will go to the next one. The next element is 3, it will print 3. The next element is 5, it will print 5. The next element is 6, it will print 6. The next element is 7, it will print 7. The next element is down here to print it up to the last element. That's the way to write a for loop. Does it make any sense? Does it make any sense? Please guys. Okay, so let's move on. Now, for one thing about like I will always say, one thing about coding is that you see this syntax. The syntax seems rather easy because what you just do is just type for X in. It's more like speaking English to the computer. But the problem is that converting this syntax into actual usable code, because I can just come here and type for X in list A and print X and show off and show you that I can code. But at the end of the day, the main point of coding is to produce things that people can actually use. Something that people can actually use. So now, we have said a lot of things. We have declared variables, we have declared data types, we have talked about arithmetic operations, we have talked about what do they call it? We've talked about conditional statement, which is conditional statements. We've talked about conditional statements. We've talked about loops. Now let's take our first major classwork, more like a classwork. Now let's say I give you a task, and I tell you that okay, find all the odd numbers between 1 to 100. How will you do it? So now let me show you exactly how that will be done. That will be like more like an example. Then I'll give a more complex problem to solve. Now, let's say I want to okay, let's say more like find the odd numbers between 1 and 100. So let's make this a raw. That doesn't give us. Okay. Now, so what we are doing now is we want to find the odd numbers between 1 and 100. Now, we know very well that 1 and 100, we can just type 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 100 in a list. But we need to think differently. Because now, the Python is simple, but it's very broad. Now, there are a lot of built-in functions in Python that help us do a lot of tedious tasks very easily. Let me give you an example of one. Now, let's say we want to find the number of the odd numbers between 1 and 100. What I simply need to say, okay, I can say for x in range. I've not brought this up before. Now, this is a very simple Python function, which is saying that in range 1 to 100, move by 1. I can just leave this. Now, I'll show you, let's run the code, then I'll show you what this does. Now, I will now say if x, remember what this does? Do you remember what this does? This is called the modulus. What this does is that is modulus is looking for the remainder, isn't it? If x modulus 2 is greater than 0. Are we there? If it is greater than 0, oh, sorry. If it's greater than 0, print x. I will explain what I just did here. Else, I'm going to introduce another new one for for loop. Else, continue. Now let's see what happens. Oh, sorry. Okay, we actually do not need the continue. We do not need it. Okay, so let's go back. Let's type this. Now you see what I just did. With just 3 lines of code, I've gotten all the odd numbers between 1 and 100. But you notice here, it stopped at 99. It stopped at 99. Now, the catch is this. This statement I just wrote here is a very simple line of code because I simply brought what we just did, which is the for. I said for x in a range of 1 to 100. Now, the range of 1 to 100 looks at 1 to 99 and not 1 to 100. So it's saying that pick all the numbers between 1 and 100. Now, I now went down inside the same for loop and I said that if the number that you have picked from that range, when you find the remainder, when you divide by 2 and you find the remainder, if the remainder is greater than 0, because normally if a number is even, it must be divisible by 2. Now, if the remainder is 0, if the remainder is greater than 0, print x. You see what I just did here? I just combined about 3 things into one. What I did is this. I've combined a for loop. I've combined a conditional statement. And I've brought in the first thing we learned, which was the print. I'm simply saying that for x in range 1 to 100, if x modulus 2 is greater than 0, print x, else don't do anything. So what the computer simply did was, he went to the first number, which is 1. He printed 1, because 1 divided by 2 is greater than 0, because it will remain 1. It will remain 1 rather. Now, he went to 2. He divided 2 by 2 and discovered that it's 0. But the condition we have given it is that it must be greater than 0 for it to print it. So he didn't print 2. He went to 3. When we do that for 3, it will still print, it will not print, it will print 3, because when you divide 3 by 2, you will get 1. You will get a remainder of 1 rather. So now this is how I think about problems when it comes to Python. You combine every single thing you've learned. For example, variables. You know that okay, I can bring in a string, I can bring in an integer, I can bring in anything I want. So I want to say, okay, if this value is greater than this value, I'm talking about in real life work now. If this value is greater than this value, let's do this. If this value is less than this value, let's do this. That's exactly what Python is. Because all these things are just mere code. You can just learn this and forget it tomorrow. Because most people do not really practice it. To be very frank. So now let's move on. Now, what if you
I
want
have a question.
Okay, please ask your question.
If you have to follow what you have just mentioned now,
Okay.
by applying this, 4 divided by 2 is 2 and is greater than 0. Why
No,
did you put 1?
no. Okay, I get your question. Now, what this particular modulus does is that it will divide 4 by 2. Now, in how many places can 2 go in 4? 2 places. 2 becomes the quotient. Is there a remainder? No. The remainder is 0. So this is not division. This is a modulus. This is telling you that pick the number, find the modulus of 2. That's find the remainder when divided by 2. If that remainder is greater than 0, print the number. If you divide 3 by 2, you get 3. 2 can go in 3 once, but it will remain 1, which means that 1 is greater than 0. So it will not print. It will print 3. It will go to 5. It will go to 4. 4 divided by 2. 2 can go in 4 in 2 places. The remainder is 0, which means it is not greater than 0. It is actually equal to 0. It will not print it. I hope I'm clear.
Yeah, you're clear. Thank you.
Okay. Now, I'm just using this modulus as a general example. Now, what if a situation whereby you want your users to actually input something into your system? When they input what they want to input into your system, you want the system to take that thing. You want the system to take that thing and use it to print something. Now, to get input in Python, use what they call the input function. I'll call it a function.
Sorry, when you speak between 1 and 100, does it take both 1 and 100 into consideration? Are they inclusive?
Okay, thank you for that. Thank you for that question. Now, if you use the range function, thank you for that wonderful question. Very important. If you use the range function, if you say range 1 to 100, it only takes 1 and 99. It doesn't take 100. Let's try it out. Normally, 101 is an odd number. So let's rerun this code. You notice it still stops at 99 because at this point he's not taking 101 into consideration. He's taking 1 to 100. You guys should not worry very much. We'll still look when we start working on real life projects. We'll still look at some of these very, very key functions, and we'll use them in real life events. We'll use them in real life events that would, for example, if we are working on maybe an income tax application, we'll use these functions to determine ranges of numbers and the likes. We'll still use them. But that question was a very reasonable question, which means that it only takes the 1, but it doesn't consider the last number. Now, in this case, if we wanted it to take between 1 and 100, we'll say range 1 to 101 because it will deduct 1 from the end at the end of the range. Now, let's get to input function. Let's assume I want my users to be able to bring in their own variables into my function and use those variables to calculate certain things. Now, what I'll do is this. I'll simply say new input 1. This is just a generic name. You can name it anything you want. Equals to input simply do this. Enter your name. Are you there? Then we say, let's copy the same thing. New input 2. Are you there? Can you hear me? Can you hear me? Hope you can all hear me. Hope you can follow. Okay, so let's move on. Now, new input 2. Enter your age. Then let's call this new input 3. Or let's call it, and so that we don't get to copy, we don't get to type too long. Let's call it NI1. NIO. That's new input 1. NIO. NIT. Enter your age. Let's call this NI4. Let's call it NIF, something like that. Now enter your gender. Now let's move on. Now let's say, now we've told our user that okay, sorry. Okay, so let's move on. Okay, all right. So look at this, please. Now we have. Are we there? Okay. All right. So now we have told the user that give us 3 values. The first value is your name. The next value is your age, and the third value is your gender. Now we want to print my name is, I want to try something that will give us an error, is NIO. We can add up strings, like we mentioned before. Then shift plus I am male. I am NIT. I am plus NIT. This will give us an error when we run it, definitely. I intentionally did that. Plus and so NIF years old. Okay, let me explain what I just did here. Now, we've declared 3 variables, NIO, NIT, and NIF. So I've told the computer that print my name is NIO, comma, I am NIT. NIT is age. Okay, NIF, this should be NIF, then this should be NIT. Okay, I've told the computer, print my name is NIO plus, that means NIO is a variable that the user is going to input, and I am NIF, and I am plus, NIF means I am male or female, then, and I am plus, okay, and dash years old. Now let's try it out. Let's rerun the code. Okay. Let's rerun. Sorry, we're supposed. Okay, so it took a while. So we've told the user, enter your name. Let's say my name is Adedokun Agunbiade. Enter your age. Let's say I'm 39. Enter your gender. Let's say I'm male. Then enter. Now you see what it has printed for me. It's telling me that my name is Adedokun Agunbiade. I am male. I did not put a space between, and I am male, and there should be a space here. No, that's why this space wasn't there. And I am 39 years old. Now, input makes you make your input more vague, because once you type input, It's telling the user that you need to impute something. Now, let me give you a quick insight into input. When we start to work on real life projects, we would never use this input. And since I've been working on actual projects, I have never used this input function. Now, input function is important when you want to run your code directly from here, or maybe you want to use your terminal window, or maybe you want to use an IDE. For example, if I'm going to work with Python and HTML, I will not use input. I will get input from a particular source, then use that input in my code. But I will hardly use input. But it is important that we know input. So we are telling the user that, okay, user, enter your name. The user entered his name. You tell the user, enter your age. The user entered his age. You tell the user, enter your gender. The user entered his gender. And you are saying, my name, you told the computer to print, my name is so and so, and I am male, and I am so and so years old. Something like that. Something like that. So that is what you use to take user input in Python. Now, it's very important to note something. Let's write in our next line of code. Let's say num1 equals input, enter a number. Please note the way I'm doing this syntax. Syntax is very important. Enter a number. Then I now declare another variable, num2. And I said num2 is equal to 50. Now, I've told my user to enter a number. And I told the computer, print num1 plus num2. Now, please, I'm sure in our minds, the computer is supposed to print correctly, isn't it? Let's watch what the computer does. Enter a number. The number is 40. Now, it's throwing me an error. Now, why is it throwing me an error? The thing is that whenever you use the input function in Python, what you are getting as a variable is a string. Now, let's try something out. Let's print the variable num1. Let's see. 50. Have you seen that variable 50 is a string? If this is shown as a string and not an integer, let's print the type. Sorry, let's use type. That will show us better. This is available via video, please. So you don't need to follow at my own pace. I know I'm a bit fast also. Okay, let's say we enter 30. You notice here, the class of the variable that was entered. Fine, the user entered 30. But what the system is saying is that it is an str. That means it is a string. That means the system is telling us that it's a string. And you know very well, I mentioned earlier that we cannot concatenate. You know very well that we cannot concatenate string and integer together. Which means that whenever you want your user to input a number and you want to use that number for numeric operation in your code, what you need to do is, instead of just writing input, just type input a number. Now, what this does is that if the user enters the number, it will convert that number from a string to an integer. If you want it to convert from a string to a float, you simply type float. That's all. But if you want it to be an integer, you simply type int the number. Now let's try this out. Let's try it again, the same thing we did. Now enter a number 50. Oh, I typed num2 rather. The first one will still not run. It's to still not run. Sorry, let's try that. Okay. We can only concatenate int to string. So we will go back to exactly what we did. We simply type int. So we are saying that we are telling the computer print the type of num1. Now we know num1 is an integer now. It's supposed to print as an integer. So let's do this. Let's type a number. Let's call that 40. Now, the class of the number now has changed from string to int. Now, this brings us up. This also teaches us something. If you have a string that contains a number, for example, if I type A equals 5,000, and I want to convert A into an, what do they call it, an integer. I can say B equals A equals int A. So let's say print type B. Have you seen it? Now, or let's call it A. Let's call it A. Now it doesn't get confusing. So you understand. Let's first print this first one. Please hope you can see what I'm doing. Now, we've declared a variable which is A, which is 5,000. We've told it, oh yeah, print the type A at this point. Then a new A now is equal to int of the former A. We want to convert it from string to integer. We'll simply say print type of A now. If you see that, it is the first A is a string, but because we have converted from string to integer, it is printing A as an integer instead of a string. Does it make any sense? Can we move on? Please confirm. Please confirm that we can move on. Okay, wonderful. I think 1 hour. One hour is actually becoming very short. 1 hour is becoming very short because of the pace we are going. 1 hour is becoming very short. It's already 7:56, which means we should have to stop this lecture now. I will send in a more like a